Good afternoon. I'm going to make a summary of what I explained to you this morning. Okay, we have matter, and matter is anything that has a volume and a mass. So matter needs to have a volume and need to have a mass. Then matter can be classified basically into two big groups. On one side, we have the pure substances, and on the other side, we have the mixtures. Okay, pure substances are those substances that cannot be separated because they are only made by one type of things. And this type of things that they are made of can be one single element or a compound. If they are made of one single element, this element is only one type of atoms of those that are in the periodic table of elements. So for example, the element can be gold or silver. In this case, this will be silver, this will be gold, can be aluminum, and many other metals. They are only one type of element. But also it's a pure substance if it is made of a compound. For example, water. In this case, the compounds, imagine water, is made of this. This is two types of elements. On one side, hydrogen, on the other side, oxygen. Like for example this, we have here an oxygen atom and two hydrogen atoms. This is what is called a molecule. So any compound is made up of molecules. An example will be water. Another example will be carbon dioxide. In this case, is made up of carbon and oxygen, like this. Well, this is a molecule, this is another one, and they form a compound. Why is a pure substance and is not a mixture? Because between the atoms, there are chemical bonds. There are chemical bonds. Bonds son enlaces, enlaces químicos. Y para entendernos, el agua, para separarla del oxígeno y el hidrógeno, no es nada fácil. Hay que hacer una electrólisis y es complicado. Luego vamos a ver de que las mezclas sí que se separan muy fácilmente. So a compound, these bonds, these chemical bonds, are not easy to separate. Okay? Then we go with mixtures. Mixtures are of two types, and they are combination of elements, compound, only two elements, two compounds, or many compounds, at least two of them. And the mixtures can be divided into two types. On one side, we have the homogeneous mixture, and on the other side, we have the heterogeneous mixtures. What is the difference between them? That the homogeneous mixtures are made of two compounds, and they cannot be distinguished. You cannot make the difference between them because one is dissolved in the other, usually. Like, for example, water and salt. We have two compounds. We have water and we have salt. That is another different compound. And these two compounds don't make chemical bonds. That's why they are mixtures. Homogeneous mixture, because you cannot make the difference. Later on, we will see a little experiment. An heterogeneous mixture, the two elements or the two compounds or the amount of elements and compounds, you can see the different substances. Like for example, if we put water and oil, this is a compound, this is another one, and the two of them do not get together, so you always can see the water and the oil in different parts. Okay, I had a mistake here. Ag is silver, Au is gold, because I put in both of them Ag. No, Au is gold. The rest of them is fine. Now let's see if you understood. Here we have different substances. We have on one side sand, we have rice, we have water, we have oil, we have pepper, and we have salt. And to end with, we have gold, which is in the form of a ring. Now, this is the classification that we have. Pure substances can be divided into element and compounds, and mixture can be homogeneous and heterogeneous mixtures. So where would you put any of these substances? Think about them, and then I will give you the solution. Well, this is the solution. Gold is a single element because it's only made up of one type of atom. And compounds, we have water, salt, and oil, which is a difficult one, but it's also a compound. The rest of them are different compounds, so they are kind of mixtures. But I'm going to do something more interesting. I'm going to mix the different substances that we have here all together, and then we are going to do homogeneous and heterogeneous mixtures. Here we are going to do a mixture. We are going to pour water on a glass, please. Okay, very good. And then we are going to put a little bit of salt. With the spoon, please. With the spoon. More. Okay, very good. Now, remove. Now you can see the difference, but when you remove, and you go on removing, you go on removing, little by little you see how the salt gets dissolved into the water. And at the end, you don't see the different substances that are salt and water, but still you can notice all the properties because the mixture is going to be salty and it's going to be wet because it has salt and water. So what type of mixture is it? Homogeneous or heterogeneous? Go on moving. Think about it. And the answer is, go on moving please. You have to move very, very, very well so everything is dissolved. And in this case, this will be considered also a solution in which the water is the solvent and the salt is the solute and the mixture is the solution. So what type of mixture is a solution? Is a homogeneous mixture. And you don't see the different components of the mixture. If you look carefully, you don't see the salt and you don't see the water. I mean, you see the water, but you don't see the salt. So you cannot make the difference. Now we are going to do another mixture. We are going to pour water inside a glass. Very well, stop it. And we are going to put oil. These are two different compounds, as in the previous example. But in this case, we are going to have a different type of mixture. Okay, take the spoon and remove gently, very fast. Try to mix them. Okay, we are mixing them very well, and we have a mixture. But what type of mixture will be? Stop, please. Take out the spoon. Very well. So as you can see, you have the oil above and the water at the bottom, so you can make the difference between the different components of the mixture. So what type of mixture is it? In this case, it will be an heterogeneous mixture. Another example, we have here water and sand. What happens if we put them together? Can you please put with a spoon? Okay, and remove. So this is tricky because at the beginning you maybe don't notice the difference between the water and the salt. And if you, for example, are mixing, I don't know, clay or even cocoa, Nesquik, Colacao, apparently they mixed. But then when you stop removing and you wait a little bit, you can see how one of the components goes down to the bottom, and if we wait enough, the water will become clear, completely clear, when the smallest substances that are floating now, that are in suspension, go down. So what type of mixture is this? If you can make the difference of the components, maybe not at the very first time, but when you wait a little bit, you see the difference. So what type of mixture is this? Homogeneous or heterogeneous? Think about it. And the answer is heterogeneous mixture. Well, mixtures don't have to be always liquid. Let's going to do a solid one. We are going to put some rice, some sand, and some pepper. So can you please? We put rice and sand, and we remove, and then we are going to put some pepper also. No, there. Put it there. No, with that. Very good. Okay, and then you remove. So in this case, you have different components, and you can separate them by physical methods. You can separate them. It's going to be a little bit difficult, but you can use a collator, and you can add water also. I'm going to add some water, please. So in this case, when I have all these components, what type of mixture is this one? Homogeneous or heterogeneous? So it's going to be a heterogeneous mixture.